welcome to U3L4 point slope form. So in this lesson, we're going to talk about point slope form equation of a line and of course apply it to our geometry concepts of parallel and perpendicular lines. So the point slope form equation for a line is useful when working with the slope and a point that is not the y-intercept. So really, this equation of a line is more useful than slope-intercept form because it applies when you have any point on a line and a slope. So for a line with a known slope m that passes through the point x1, y1, the following equation will describe all points on the line. So what is similar to slope-intercept form here is that, of course, we have y and x still, okay? We have m, and m is actually located before x as it was before, except there's these parentheses here. Okay, so we still have our slope here. A big difference here, though, is that we are including the fact that we have a coordinate, x1, y1, versus just a y-intercept, okay? So this can be any random coordinate. So keep in mind, though, be careful here, because the equation itself has y minus y1 and x minus x1, you can look at that as being the opposite, right, of the number. So when you're looking at the equation, you're actually going to be looking for the opposite of the number, and that's because of these minus signs here, okay? So keep that in mind. Another thing to notice is that your y value from your coordinate will always be located where the y variable is. Same with the x value of your coordinate will be located where x is. Okay, so taking a look at example 1, write the equation of the line with the following slope that passes through the point given. Okay, perfect. So I'm going to go ahead and label my point, so x1, y1. And we have our slope is m equals 6. So it's going to be y minus y1. So y minus, and then your y1 value, which is -5, is equal to m, which is your slope. So that's 6 here. Parentheses, x minus your x value, so x minus 3. And then if you have any double negatives, you're going to want to change that into a plus sign. Okay, so y plus 5 is equal to 6, parentheses, x minus 3. And then as I was pointing out earlier, keep in mind that the coordinate itself, the numbers in the coordinate, right, are going to be the opposite of what you see in the equation. Okay, they're going to be the opposite of what you see in the equation. If it's x minus 3, the coordinate itself was a positive 3 for the x value, and the plus 5 for y, that was a negative 5. Okay, perfect. Okay, for B, let's take a look. We have x1 and y1. We're going to do y minus y1. So y minus -4 is equal to m, -2/5, parentheses, x minus x, so x minus -1. Change these both to plus, so y plus 4 is equal to -2/5, x plus 1. And this will be your final equation there. All right, keep going. So now we have example 2, graph the linear equation. So it's easy to graph a line in slope-intercept form. You graph the y-intercept, and then you use your slope to move, if you will, right, to find additional points. Same idea here. It's just instead of a y-intercept, you're going to use the other random point that you can take from the equation. So first thing I'm going to write down is my slope, okay? So my slope here is going to be the number in front of the parentheses, and that's going to be the -2. And then for my coordinate, remember, take the x part of the coordinate from where x is, the y part of the coordinate from where y is, but take the opposite of what you see. So because I see a positive 1 where x is, that's going to be a -1 in my coordinate. Because I see a -3 where y is, that's going to be a positive 3 in my coordinate. Now all you have to do is you're going to plot this point. First. So -1, 3. And that's going to take the place of what you would usually begin with, which would be your y-intercept. Right now, you're going to begin with this point, because this is the only point that you know that's on the line right now. And then we're going to use our slope. Our slope is -2, a.k.a. -2/1. So you're going to go down 2 and to the right 1. So down 2 to the right 1, down 2 to the right 1, down 2, right 1, down 2, right 1. And we can reverse it one time. We can go up 2 and left 1 just one time. And then, just like always, draw your line with arrows, and you're done. So again, you're graphing a line just as you would in slope-intercept, except instead of a y-intercept, you have another point. All right, let's do that one more time. So now we have our slope is in front of our x, so m is 1/3. And then our coordinate is going to be opposite of +2, which is -2, opposite of +5, which is -5. Don't forget that the x part of your coordinate comes from where x is in the equation. same with y. Okay, the y part of your coordinate comes from where y is in your equation. Okay. Now, plot that point first, so -2, -5. And now we want to use our slope. So positive slope is going to be up and right. So from our coordinate -2, -5, we're going to go up 1, right 3, up 1, right 3, and we only have space to do it twice before we run out of space. So that's fine. And there we go. All right, continuing on, example 3. Given the line y minus 4 equals 3 parentheses x minus 2, graph the line on the grid provided. Perfect. So another chance for us to graph this. So our slope is always in front of the parentheses, in front of the x. So our slope is 3, or 3 over 1, which means we go up and right. And then our coordinate here is going to be the opposite of -2, so +2, opposite of -4, which is +4. So +2, go to the right 2, and then up 4. 1, 2, 3, 4. So +2, so x, right? +2, up 4. Okay, so that's where we're going to start. Okay, once we start at that coordinate, we are going to go up 3, right 1. Problem, we can't go up 3. We will literally run out of graph, right? If we try to go up 3, 1, 2, we can't. So instead, we're going to reverse this. So we're going to go down and left instead. Okay, so down 3, 1, 2, 3, left 1. Down 3, left 1, down 3, left 1. Make sure after you draw this line that it still has a positive slope. Okay, keep yourself from making any mistakes there. Make sure it still has a positive slope. Okay, there's our line. For part B, it says, then solve for y to convert the given equation to slope-intercept line. Y equals mx plus b. What do you notice about the two lines? Okay, so what we're going to do here is a little bit of manipulation, really just stuff we've done in the past. So we have y, take our original equation, y minus 4 equals 3, parentheses x minus 2. And we just want to rearrange things a little bit in order to make it look like y equals mx plus b and just see what we notice. Okay, so we have y minus 4 equals 3. Since we have parentheses, we want to distribute first. So let's distribute that 3. So y minus 4 equals 3 times x minus 3 times 2. So 3x minus 6. And then what we can do to get y by itself so it looks like y equals mx plus b is we can add 4 to both sides. Now, because it's a constant 4, you want to add it to the -6, not to the 3x. Now we're going to have y equals 3x minus 2. And then it wants us to graph that line. So let me take a different color and we're going to graph that line. Our b is -2, so we're going to start on -2. And then our slope is still 3 over 1, right? It's up 3, right 1. So we're going to go up 3, right 1, up 3, right 1. And what do we see that's happening here? So we're going through the same coordinates we already went through, right? When I draw this line, it's going to be the same line that we already had. So what do you notice about those two lines? They are the same line. Okay, and the reason I wanted to do this little activity with you is to show you guys that if I start with one line, no matter how I make it look, right? If I change how it looks by manipulating and solving, I'm still going to have the same line in the end. I graphed the same line twice, right? So each equation is going to look slightly different, but no matter what, the equation of a line is the same no matter how you rearrange it, okay? All right, last but not least, is the line y equals -1/3 x plus 5 parallel or perpendicular to the original line? Y minus 4 equals 3, parentheses x minus 2, justify. Now, you could go graph this line and then try to look at it, but then, of course, you're kind of guessing a little bit. I want to use our facts of what we know about parallel and perpendicular. And so just recall, to be parallel, we would have to know that they had the same slope. To be perpendicular, we would have to know that they had opposite reciprocal slopes. I guess I better write that up. Opposite reciprocal slopes. So, looking at the two equations, where are the slopes in those two equations? Well, for the first one, it's right in front of x, -1/3. And for the second one, it's also right in front of x. It's 3. So if we look at the slope of 3 versus the slope of -1/3, we can determine are they the same or are they opposite reciprocals. And what we can see here is they're opposite reciprocals. If we were to put the one under the 3, we can especially see that they're flipped, right? They're reciprocals. One's positive, one's negative. So we can say the lines are perpendicular we have to justify. So we can say because their slopes are opposite reciprocals. Okay, perfect. That's it for these notes. Thanks for watching, everybody. Have a great day.